So how do you convert between moles and mass? Well, again, we're going to use dimensional analysis, and dimensional analysis always involves a conversion factor. So we need a conversion factor to convert between moles and mass or moles and grams. The equivalent is 1 mole equals the gram formula mass of a substance, where the gram formula mass is the mass of 1 mole of a substance in grams, and that's numerically equivalent to the mass of the substance in atomic mass units. Here there is no one set number. If you remember moles and particles, we always said 1 mole equals Avogadro's number, or 6.02 times 10 to the 23rd representative particles. But every different substance has a different mass, so there's no one set number. We'll figure out what those numbers are, how to calculate it in just a minute. A little bit more terminology. The gram formula mass of an ionic compound is called the gram formula mass, the GFM, because the formula unit's the representative particle of an ionic compound. The gram molecular mass is called the GMM because the molecule is the representative particle of a molecular compound. And the gram atomic mass is called the GAM because the atom is the representative particle of an element. So just as there's 3 different types of representative particles, there's 3 different labels for the different kinds of molar masses. So again, how do we figure out the molar mass of a substance? Well, you go to the periodic table, and for example, zinc. Zinc, you can find that the atomic mass is 65.39 atomic mass units. Again, the atomic mass is the average mass of an atom of that element, and therefore 1 mole, or 6.02 times 10 to the 23rd representative particles or atoms, has a mass of 65.39 grams. In other words, the average mass of an atom is in AMUs. The average mass of a mole is in grams, but numerically they are equivalent to each other. We are always going to round to 2 decimal places. So if this is the periodic table's atomic mass, we're going to round that to 12.01 for the gram atomic mass. Same thing for nitrogen. If this is the atomic mass, this is going to be the molar mass of 1 mole of nitrogen atoms. Oxygen is going to round to 16.00 grams per mole, and fluorine is going to round to 19.00 grams per mole. So important that you always round to 2 decimal places. If you have a compound, now you simply have to add the atoms together. So 1 oxygen atom has a molar mass of 16.00 grams per mole. And if oxygen is O2, we're just going to multiply that by 2 to get 32 grams per mole. If we have water, water's made up of 2 hydrogen atoms and an oxygen atoms. So we're going to round to 2 decimal places and then multiply it by 2 to get the mass of hydrogen in water. And then oxygen, there's only 1 oxygen atom, and so we're going to leave that at 16, add them together. The molar mass of water is 18.02 grams per mole, 2 hydrogens and 1 oxygen. If we have disulfur trioxide, again, first thing I do is figure out what is the chemical formula of disulfur trioxide. It is S2O3, so 2 sulfurs and 3 oxygens. So we're going to multiply the mass of sulfur by 2, the mass of oxygen by 3, add it together, gives you the molar mass of disulfur trioxide. If we have C12H22O11, it's really the exact same thing. It's just more particles. So we have 12 atoms of carbon. So we multiply carbon's mass by 12. 22 atoms of hydrogen. So we multiply hydrogen's mass by 22. And we have 11 atoms of oxygen. So we multiply oxygens by 11, comes out to 342.34 grams per mole. Again, all rounded to 2 decimal places. If you have something in parentheses, you got to be a little bit more careful. that 2 has to be distributed through the nitrogen and the hydrogen. So really we have 2 nitrogen atoms, 2 times the 1, and so 2 times the mass of nitrogen. There's going to be 8 hydrogens, 2 times the 4, and then there's 1 sulfur and 4 oxygens. And so the molar mass of ammonium sulfate is going to be 2 times the nitrogen plus 8 times the hydrogen plus the sulfur plus 4 times the oxygen, comes out 132.17 grams per mole. And so quite straightforward to figure out the molar mass of a substance, but that gives you an equivalent. This is the mass of 1 mole. So if I had 1 mole of that, I'd have 132.17 grams, also have 6.02 times 10 to the 23rd representative particles. If I had 2 moles of that, it would be 2 times that number. If I had 2.5 moles, it would be 2.5 times that number. In other words, that is an equivalent that allows me to convert between mass and moles. So if I asked you, what is the mass of 5.50 moles of aluminum chloride? First thing you would need to do is to figure out what is the mass of 1 mole of aluminum chloride, because that is going to be your equivalent. So aluminum chloride is made up of 1 mole of aluminum, 3 moles of chlorine, and so the molar mass is 133.33 grams per mole. So that gives me equivalent, a relationship between moles and grams. And if I want to convert between moles and grams, now I want the molar mass on top. So moles and moles are going to cancel. And so if 1 mole is 133.33, 5.5 moles can be 5.5 times as much. Multiplying through, rounding to 3 significant figures, gives me 733 grams. So that's an example of converting moles to grams. If we want to go the other way around, go grams to moles. Again, we have the same substance, aluminum chloride, and so we already figured out 1 mole is equivalent to 133.33 grams. Now I'm going to put the 133 grams on bottom, so grams and grams are going to cancel. In other words, now I have to divide by the molar mass to figure out the number of moles. So 420 divided by 133.33 is going to give me 3.1501 moles. Now I've got 5 significant figures in my answer.